So I've been meaning to make a video, kind of like a walkthrough about DynamoDB for a while now. I've been using DynamoDB at a work project for about 5 years. I'm not an expert at Dynamo, but I have learned some things along the way, and I wanted to share those things I learned with you, hopefully in this video. So I am going to start with the basics of, like, for beginners, how do you even create a table? How do you write stuff to the table? But I do plan to just drop various bits of information along the way that should help you understand how to use DynamoDB more efficiently, because there are a lot of things you need to read about. First thing I recommend, before you even get started with DynamoDB, you need to go and read these best practices, because if you design your table wrong, I think stuff is going to be a lot more harder later on to refactor in your system. So read about the best practices. Also, I recommend go reading up on the pricing, which I'll kind of talk about in this video as well. There's different modes to your Dynamo table, and depending on the mode that you have set, you could be charged differently. For the most part, DynamoDB is very cheap, but there are cases where if you need to do like a full table scan to update every single row in the table, that's when you might get a larger bill for that operation. But let's just start with the basics. So DynamoDB is a key value store, basically, where every piece of data that you're storing has to have a key and then has to have a secondary sort key. The more correct term for those is PK, partition key, and then SK, which is sort key. So if you imagine DynamoDB as like a giant spreadsheet, every row in the spreadsheet is like the object, the JSON object that you want to store, because again, Dynamo is a NoSQL database. You can kind of just throw in various JSON related objects into it. But the main thing you have to understand is that every item that you store in your table has to have at least a PK. Okay, so for example, if we're dealing with a table that needs to store users and user information, the PK, maybe you want to put user pipe 1. Okay, so this is user 1. You can put whatever you want here. This is just a string. The best practices for Dynamo recommend that this be something that will not have very many collisions. So for example, a PK, you should probably be always storing some type of UID, some type of very unique ID. And then you could potentially have multiple records attached to that same PK if you want to. But what I would not do is if you just have a PK called users, and then over here you have like user 1, and then you have a PK called users, and over here you have user 2, this can create something called a hot partition, where basically you're storing a ton of data all in the same PK. And when you do a read, you're going to see a lot of throttling issues. Throttling is something basically if you try to read too many things at once from your table, and your table is not set up to handle that capacity, you're going to get a bunch of errors in your Node.js code. And you have to basically wrap your code with try catches and make sure that you retry if you get throttling errors. But that's more advanced. We'll talk about that later. But what I like to do with my tables is I like to put some type of prefix on what the thing is, right? Because DynamoDB recommends a one table approach. If you are creating multiple tables for your various entities in your system, you're doing DynamoDB incorrectly. The way you're supposed to do it is, let's say you have users. You want to put users in some type of delimiter, maybe a pipe I like using. Now, let's not even worry about the sort key. I'm jumping around right here. But for the PK, this is what I do if you have users and then maybe you have orders. Okay, you have an order called ABC. And then you want to have, I don't know, a receipt. And then maybe you have a message. Message you can do like 999. So imagine like your SQL database, you have all these different tables. Basically take your table name, use it as a prefix, and then use a unique identifier for that record here in your PK. Now it's good to think abstractly. Remember, this is just an arbitrary string, right? So you could do composite keys inside of your PK here. If you wanted to do orders ABC, that's something that you could potentially do, and then store all your order information in this row here. Because as long as you have the user ID and then the order ID, you can look up this entire row using this PK. So these are some of the things you have to keep in mind, but we're going to try to take a step back. I got into the weeds of stuff. We're going to keep this simple. So the second thing I want to talk about is the SK, which is the sort key. So the sort key allows you to have another identifier for putting, in addition to your PK, that kind of acts like the composite key, but there's a lot of flexibility around Dynamo for doing queries where you can actually like check, like if I were to do this, let's say user 1 has an order called A, and then user 1 also has an order called B, and then user 1 also has an order called C. Okay, so let's say this is like a AWS shopping cart, a user's placing some orders, something like that. You can store the orders like this. And then, but you can also store, let's say users have messages. Okay, user 1 has a message 1, has a message 2, has a message 3. Okay. So in Dynamo, you can do a query and you say, give me all the records that have a PK of users pipe 1. Okay, so I'll say like query where PK is equal to users pipe 1, but then also say and SK starts with messages. This is something that's really important to understand. Basically, you can do a query against Dynamo and say, give me basically these. Give me all the messages that are attached to a user. And I'm sorry, it's not starts with, it's like begins with, something like that. So if you go to the docs and look at this key condition expressions for query operations, you'll get this information where you can kind of do less than or equal to queries. But also there's like a begins with filter. There's some other things too. I'd recommend reading through this. But what this allows you to do, like I said, is you can query all users and all the messages that are attached to users. Okay, and that's pretty cool. So now let's pretend like we're storing logs. All right, so logs, again, you don't want to have hot partitions. So you'd probably want to have some type of date. Maybe you could just store logs for that particular day if you don't have too many logs in that day. And then over here, you can store in your SK, you could store timestamps. Put these in incrementing order, timestamps. Now again, like I mentioned with the query, you could say, give me all of the PKs that start with logs of today. And I could say, give me the SK that's greater than some value. So I could say like, make sure it's greater than 11 o'clock. And the SK is less than, I don't know, 12 o'clock. That kind of makes sense. I'm just doing pseudocode here. I don't know if the syntax I'm putting out is 100% accurate, but that's kind of the idea. So once you understand how you can structure your records and what you need to specify for your PK and SK, then you can start designing your table a little bit better. Now, one of the best practices with Dynamo is they say before you even create your table, you should understand your data access patterns. If you don't know what you're building, I would recommend not using Dynamo. It's just because SQL just gives you a lot more flexibility to quickly query and create indexes on various things. Dynamo, on the other hand, once you create this PK and SK, you can't change it. So the only way to modify this stuff is to either create a global secondary index or delete the table or migrate all your data from one table to another table that was set up in a different way. So what do I mean by that? Let's just go ahead and reduce this to something simpler. So that kind of leads me to another discussion of how do I query for order of C? In Dynamo, there's no way to query by SK. You have to have the partition key in order to do a query or a lookup. So now we have data that's in our table. We have no way to get it. How would you get order number C? Well, there's something called a GSI, a global secondary index, that you can add to your table so that you can kind of change the PK when you do queries. Okay, so I'm going to say GSI1 PK. Again, I would recommend making these names very generic because you might have various types of data being stored in your GSI1 PKs that, like for example, a message might have a different type of GSI1 PK once it's put here. An order might have a different one here. Okay, so one way that you can achieve this is I want to store the order ID, so I'll say order C, inside this GSI1 PK. Now what this allows you to do is in Dynamo, you can actually specify what GSI you want to do the query on, right? So I can say like GSI is equal to GSI1, like this. And then I can also say like where GSI1 PK is equal to order of C and SK is equal to order of C. Again, this is pseudocode. It could be incorrect in terms of the syntax, but this is the idea. You're basically saying use this column as the PK, use this column as the SK, give me the record whose PK and SK are order C. So that's how you can kind of do like a reverse lookup to get the items that you need. Now there are some downsides of using GSI1 PK. And if you read the best practices of Dynamo, they say try to avoid using too many of these because every time you add one, basically when you write an entry into Dynamo, it has to also write that same record into your GSI1 indexes or whatever they're called. Okay, so basically if your table does, let's say 100 write count units every day, when you add a GSI1 PK, you just doubled your write costs. Now you're basically doing 200 write count units because behind the scenes, they have to replicate your entry into some other type of data store so that you can actually do these type of lookups. If you keep adding different GSI1 PKs, you're basically just multiplying your write costs in your table. And then also if you read their docs, they say it could potentially slow down your writes every time you add more of these, which is why, leads me to my first point, make sure you understand what you're building before you start using Dynamo. Understand your query access patterns so that you don't screw up what you're storing in here, or else you're going to have to do a lot of rework to rearrange some stuff. Now, unfortunately, we're probably going to be looking at the spreadsheet for most of this video, but there's a lot of good information that I'm going to be telling about this spreadsheet. So again, what's another approach? Let's say you don't want to add a GSI1 PK. Okay, so another approach is doing something called denormalization, where you can basically take this record and you can store it as a separate entry. Okay, so now you have basically two duplicate things in your system, which allows you to do a PK-SK lookup directly without the GSI1 PK. So if you imagine that you didn't have this, well, now I have a way to get the record. But the issue with this approach is that if someone were to come along and update this record, you need to make sure that you go along and update this record, right? If you're actually denormalizing, you're copying, like, let's just pretend the order has like a product on it. So this would be product of like apples. You basically have that exact same thing cloned down here. And whenever you update this one, you need to make sure in your system, your Node.js code, you go back and you update this one. So denormalization, I would kind of avoid if you can. It's just going to be a lot harder to like make sure you update all the entries. It's more of a performance thing. If you just have records that need to be quickly looked up, you don't need to like update everywhere else in your system instantly. You can do that. Another approach is using something called like a mapping record. So a mapping record, there might be a more correct term for this, is that here you don't actually store any information about the order. You just know that there's a reference from user 1 to order C, so that when you do a query and you say, give me all the orders for user 1, in your Node.js code, you can then do a loop and do a batch get and say, hey, give me order A, B, and C, and that's going to go do some lookups for orders A, B, and C. Again, not the most performant, because now you have to do a query, and then once you get the results for that query, you have to do a batch get over these three records so that you can get orders A, B, and C. So these are just different strategies you kind of have to keep in mind. I think the approach is they recommend using GSI1 PK, but like I said, there's drawbacks to using too many of them. So these are things you have to kind of keep in your mind, I guess. Okay, so now let's talk about how do you do like many-to-many relationships. Let's say a user has many orders, but an order can be attached to many users. Let's say, I'm going to go ahead and just get rid of this messages stuff. Let's say we have a user's ID of 2, but that also belongs to order A. So then your query pattern is, how do I get all of the users who are attached to order A? Okay. Again, you'd have to do some type of GSI1, and you want to make that be on your order ID. So this would be order A. Now, one thing I didn't really mention is that when you make a GSI, you have to specify what is going to be your sort key. So this one will be your PK, technically. Over here, this one could be your GSI1 sort key. Okay, this happens when you define it. You can't change this. So when you first define that GSI, you can specify, okay, what property will be my PK? What property will be my sort key? So, and this is actually outlined in their best practices. If you go to the many-to-many relationships, they talk about this adjacency list design pattern, where I'm basically showing the same thing, where you have a PK and an SK, but then you create a GSI, and your GSI's SK actually is the partition key of your previous table. So if you're kind of confused, which you might be, what we're trying to do here is you have a user of 1, and they have an order of A. But then if you also have user 2 and they're somehow attached to order A, how do you get the information back? How do I do a query and give me all the users who are attached to this order? Okay, that's what the adjacency list pattern kind of lets you do. And if you have your table set up in this way, it allows you to do that. Basically, make sure you always store your SK inside the PK of a GSI1 PK. So at this point, you guys might be confused. Half of you probably dropped off from this video, but these are some of the core things you need to understand about DynamoDB. And I think if you don't understand these best practices and like the different approaches you can use, you're going to just start coding things incorrectly in your DynamoDB table, which is going to cause some rework later on. But let's go to Dynamo. Let's actually create a table and let's talk about this. So I'm going to go to create table. And I'm going to say my awesome table. And here you can see we can define a PK and a sort key, right? A partition key and a sort key. This is exactly what I showed you in the spreadsheet, where we're going to just go ahead and put a generic PK here, and we're going to put a generic SK here. That gives you flexibility I would say if you're going to put like a user ID and then you put like a time, like now you just made your PKs and SKs very, very specific. But if you're going to do the one table DynamoDB approach, I would highly recommend just making these generic PKs and SKs. All right, so let's move on to the settings of the table. So there's two different types of tables. You can use on demand and you can use provisioned. Provisioned, I believe, is the default. And basically you're telling Dynamo that I want at all times the ability to have 10 capacity units on this table. Okay, and you get to specify between the read capacity and the write capacity. So let's talk about what this means. So if you go to the pricing page, they'll kind of talk you through this. So for the reading, basically what they do is they take the item that you're trying to read from the database, they divide it by 4 and whatever's left over, and then for any remainder, they round up. So for example, if you have an item that's 20 kilobytes in your database or 21 kilobytes, divide that by 4, you're going to get 5 point something. They round that up to 6. So you're going to get charged, I believe, 6 read request units for that item. Okay, now remember, if you're doing a query, you're going to get tons of items back. So you have to understand, like, what is the total data that's getting sent back from the table, divided by 4, and that's how much basically the read request units you're going to get charged. Now that's for a strongly consistent read. If you're just doing an eventually consistent read, which is another topic we're going to have to talk about, I think they charge you half of a read request unit. It's confusing. But anyway, they do the same thing with writing items. So for every kilobyte, you get charged 1 write request unit. And then if there's some terminology for transactions, require 2 write request units. But basically the whole idea of this write request unit and read request unit, they're very important because when it comes to your provisioned capacity table, if you do too many writes or too many reads from your table, you're going to get a bunch of errors, right? Your node code is going to throw a bunch of throttling exceptions, and then you're just not going to get that data back. Okay? And the only way to get that data is either scale up your write capacity units or scale up your read capacity units. Now they have this cool auto scaling feature you can use where you can kind of like have it automatically scale down, because I do believe when you're using provision capacity, you're charged based on every minute or whatever that the table has been scaled up to like 10. Okay? I have to go find the docs for that. It's kind of confusing as well. This is kind of like having a dedicated VM that you're always going to be charged for it running, but you're charged based on what is the current capacity units of that machine as it's scaling up and down. So if you have no traffic, it'll scale down to 1. You only get charged 1 capacity units per, I don't know, minute or something. We like to use on demand where we work, and the pricing is a little bit different from what I understand. Basically, you're charged based on these read and write request units. So if you scroll down here and find, you get charged 1.25 million per write request unit. You get charged 25 cents per read request unit. So that's with the standard table. Yeah, so on demand basically will behind the scenes scale up your machine if you have a lot of traffic and scale it back down. But I do believe you can still hit throttling errors as it's like scaling for you. So make sure you still have code that's like checking to make sure that stuff is catching for throttling exceptions. Encryption at rest. I don't know too much about this, honestly. You can probably set your own AMS key if you want to use that. I think just using owned by Amazon DB is probably fine for encrypting your data at rest. If you want to live on the edge, you could say no. I'm just going to go ahead and create the table, and then we have a table that's created called My Awesome Table. And while that's creating, let's just go ahead and move over to my node code real quick, because I do want to give like a little example of writing some information to this. All right, so our table is created, and you have some settings you can go through here and try to understand. There's also an Explore Table button. If you click that, you can actually go and start querying. Like I mentioned before, you can do queries on your table to get some information. Right now, our table is empty. So what I'm going to do is I'm going to show you some Node.js code of how you can write a record to this table. Okay, there's a package with AWS V3 SDK that you import that gives you access to a DynamoDB client, and you can start putting items into that table by basically running this type of code. So you do DynamoDB client send, and then you give it an object where you construct a new put item command instance. You give it some information about what table you want to write to, and then also what the item is going to look like. Now, the main thing I want to point out here is notice that there's a PK and an SK here, and it's using that same format that I showed you in the spreadsheet. Other than those two things that are going to be required, because when I set up the table, I said that there was a PK and there was an SK. So now every time you write to this table, you have to have those two things defined when you're putting items. Everything else is up to you. You can just put whatever you want here. Now, another thing you might notice is that the syntax for this is really weird, right? This is the DynamoDB item syntax where basically you have to define a type. Like for example, PK is an object where S is a string, N is a number. They have one for M for map, I believe. They have maps, they have booleans, they have sets. So if you want to store an array, actually no, set, what is set? I think it's L, like a list. All right, so for right now, we're just going to do a string and a number. Let's try running this code and see if it works. Okay, item added successfully. You get some metadata back. Good enough. So let's go back. Before I run the query, I'm going to talk about a scan. So a scan basically runs through every single item in your table, which obviously is going to be very, very expensive to run because you're doing a bunch of read request units over every single item in your table. And it's also slow. If you have 16 million items, this scan will take a very long time to do. So personally, I would never even use scan unless you're just like playing around and trying to learn. You probably always want to use a query. Okay, so just keep it on query. And then what you can do here is you can select your table or your index. Remember that GSI I talked about? I'll show you, I'll create one and I'll show you that. You can say, give me back all the attributes, or you can specify certain attributes. I do believe, even if you're trying to query and select certain attributes, you will still be charged the same amount because the filtering kind of happens on the backend side of things after Dynamo has already done your query. So anyway, we have a PK here. Let's just go ahead and search for user of 1. And then let's also search the SK. Remember where I talked about there's some things you can do like begins with? Here are the options for SK searches. I'm going to go ahead and say, give me also the SK equal to user 1. I'm going to do run. It tells you how much read capacity units it consumed. So even though it returned one item down here, it still consumed 0.5 read capacity units. But here it is. We have our item. We can go and we can look at it. If you wanted to do a JSON format, it's hidden behind my name, but you can switch this over to the JSON format. You can also view it as raw JSON instead of this DynamoDB JSON format. Okay, you can come in here, you can edit it. I can just edit this if I wanted to, and I could save. Okay, and that's kind of the gist of it, right? We just added our first item in the Dynamo. Now, if you wanted to query for that inside a node, you can do that. Let's go ahead and modify this. I'm going to make a query command here. I'm going to import that. And we want to basically run that query command. The way that you do Dynamo queries, it's kind of weird. The syntax is kind of weird. Basically, you have to provide key condition expressions. This is like the actual query you're trying to do. And then you have to kind of like in this other object, you have to fill in some properties that are going to be like string replaced. So like whatever I define here with the colon here, that's just going to be replaced with this string value. It's weird, but there's also another thing I'll talk about that makes this a lot easier. But again, let's just look for a user ID of 1. And we're going to go ahead and change this to PK. And this is going to be the value of PK. And then instead of partition key, this needs to be the actual name that we named when we set up the table. So I think I should be able to run this and we should get back all of the user information that has a PK of user of 1. So we got some items back. Let me just go ahead and do items here so we can maybe look at them. And now you have that really weird looking object that is really annoying to work with. So how do you convert this to actual JSON? Okay, luckily there is a marshal and an unmarshal function that they provide us. So if I want to kind of loop through all the items that are in this array, I can pass this to an unmarshal function, which I need to import. So let me just go ahead and do this. Import. So now if I run this again, it should basically take that DynamoDB JSON format and convert it to, oh, I also need to install this. Let's just go ahead and install it. Run this again. There we go. So now we actually have like real looking JSON data, which is good. So as you can tell, this syntax kind of sucks and the data that gets returned from the results also kind of sucks. So if you want to use something called the DynamoDB doc client, this is something that you could do. So let's just take this example and we're going to try to use this because I do think it makes the code a lot easier to use. Now, unfortunately, you have to like install from different packages. So I have to install this libdynamo package. Go over here, install that. And then I have to import it. Pass the client here. Okay, so what this allows you to do is instead of using the DynamoDB client, you can actually use the doc client to send different types of commands. Now, this might trip you up. You need to make sure you're importing the correct methods from the correct libraries if you're using the doc client. For example, if I wanted to do a query command, you want to make sure you import it from this one and not this one. Okay, so let's do the same query command. I'm going to go ahead and just do a query command. And I think what I can do is just copy this code. I'm going to put it here. Clean this up a little bit. Now, I do believe that the query is going to be consistent with how it was before. Let's just try this out. I'm going to go ahead and paste this in. If you go down here in the example, they have key, condition, expression attributes, consistent read, etc. So I think it's the same thing. But if I were to go ahead and just delete that and say console log response item. Okay, so the main takeaway that I'm going to point out with the doc client is that you don't have to do the weird Dynamo syntax anymore. You can just do normal JSON, and notice that the expression attributes, I'm just saying give me the PK where it's equal to this. Instead of having to do that weird string of that, it's basically doing the unmarshalling and marshalling for you with all this DynamoDB JSON. So same approach is a little bit cleaner. I would recommend using the doc client unless for some reason you can't use it. And then if you look at the data that comes back, you'll notice that it's also unmarshaled for us automatically. We didn't have to run that marshal command. So everything I showed you was using like the baked in AWS SDK. There's something called ElectroDB, which is built specifically for DynamoDB for doing these type of queries. Okay, so I highly recommend look at this library if you want to be able to move fast with Dynamo, because writing all these query expressions by hand, it's not a really fun developer experience. Okay, it's nicer if you can actually just use an ORM type of syntax to read and write and query from Dynamo. So go check out ElectroDB. I'm not going to dive into how this works. I'll leave that to you. So I've kind of talked about how you can do your query patterns, how you can set up your tables, how you can query and get and write from Node. I talked about the doc client. I talked about access patterns of like PKs and SKs and GSIs. I didn't show you how to actually set up a GSI. So if you click on indexes here, you can create a new index. So as I mentioned in that example, if you want to make a new partition key, so GSI1 PK, and then I want to set the sort key equal to my existing PK, I can do that. And then I'll name this GSI1 index. I'm going to keep this on demand. I'm going to project all the attributes. This is something that you can do to basically, if you only want to pull over a certain amount of data, because remember, when you make a GSI, you're basically, every time you do a write, that data is getting cloned and written to this other index. So if you want to save on data, you only want to send over a certain amount of keys. You can do that. I'm just going to go ahead and say all because my table is small. But at some point, you might need to do performance tuning and just only send over certain things that are needed in this index. All right, so now the index is creating. And if we want to basically insert some items, right? Let's go back to here. I'm going to create an item. I'm going to say user of 1, and I'll say order of A. And also what I'm going to do is add another attribute. Now, I don't like this view. I'm going to switch it over to JSON, and I'm going to say, click on this. There's a way to default it, I believe, so it always shows this. And then over here, I'm going to say GSI1 PK is equal to user of 1. All right, so I set up the table with some examples of doing that reverse kind of lookup that we talked about here, where we have in the GSI1 PK, we just basically put order A. Okay, so this is order A, and that allows us to do a query and give us all the users who are attached to order A, if that makes sense. Now, again, you still have some type of like denormalization probably going on here if you have user 2 has an order A and user 1 has an order A. But again, the idea is just like the reverse lookup. How do you achieve that? So I could do this in Node just using the UI. I think it's easy enough. But now you can see if you click on this dropdown, you get a GSI1 index that we created. And then you can go over here and I can say, give me, like I say, give me GSI1 PK with order A. And then the sort key has to begin with user. So doing that query is actually throwing an error, and it's because this GSI1 index is still creating. So this is something interesting about Dynamo. Like my Dynamo table literally has probably like 5 kilobytes worth of data or less, has 2 items in it. But for some reason, it's taking quite a long time just to create the global secondary index. But in the meantime, let's talk about some stuff. So there is another concept that is really important, and that is called global tables. In your system, you might have your Dynamo table here in East 1. Okay, but what if you wanted users who live on the West Coast to be able to query that data faster, right? You don't want that latency from the West Coast of the US to have to go all the way to the East to get that data. So that's where you have something called replicas. So DynamoDB global tables, which basically just sets up a replica from one table that you'll consider your main table, and then it creates a replica to basically every time you write data into this table, it'll send over that data to the West. It'll also do the same approach. If you were to write to the West, it'll eventually write that data back over to East. Okay, again, this is all eventually consistent. So if you were to write something into East and then someone were to do a query, that item might take a couple of seconds to show up on the West and vice versa. But this is an option. If you go to global tables and you create a replica, you can basically specify another region that you want to sync these tables up with. Now, I do believe this is a bi-directional replication. At least that's what I've seen in practice. So I think once you create the replica, like they're going to replicate back and forth. But correct me in the comments if I'm wrong, but that's what I've been seeing in our system using this for a while. Another thing that's really important to talk about is your DynamoDB streams. When you find that you can't do certain queries in your Dynamo table because it's just super hard to do certain queries, this isn't SQL, you can't just add a where clause. You might realize that you want to kind of replicate your data to OpenSearch or some type of reverse index system or database. So this is where DynamoDB streams comes into play. If we kind of reduce this to something simple, we have a Dynamo table here, and when a user tries to write some data, so we have a user, he wants to write a record here. There's something called a DynamoDB stream that you can hook up like this, where you can actually have like a Lambda process events as they're being sent to your table, right? So as a user writes an item or puts an item, that put item request is going to get kind of wrapped up as an event, and then you can bundle those. I think it's like 10 or 100 in a batch, and you can send those over in your stream, and then you can have another process that's kind of reading on those Kinesis streams, reading on those Dynamo stream events, and doing something with them. So in our case, what we do is we actually have an Elasticsearch cluster, or I guess you call it OpenSearch because we're using the AWS equivalent. And as those items are coming over, we look at the PK, we look at the item type, and we basically index that into Elasticsearch so that other places in our application, we can quickly do queries really easily based on the data that's getting written. So you may end up needing to do something on your system where you have some better database. I shouldn't say better database, but you have a more query-friendly database where you send over a subset of your data so that allows your users to be able to do queries based on that. The DynamoDB streams are pretty cool. So there's point-in-time recovery. I mean, I recommend probably having this turned on in case you were to accidentally like delete a bunch of data. You can just go back and revert your table back to up to 35 days, I believe. You can also manually create backups. So if you're about to do something that's kind of risky, you can just create a backup and then you can restore that if you need to. I'm trying to see what else is kind of important. This graph, the monitor graph, is important, especially for the read throttle events and the write throttle events. So you want to kind of keep an eye out for this. If you start seeing any type of throttle events, that either means you need to scale up your table if you're using like a provision capacity type of approach, or you need to find a way to like not send so many requests to your table all at once. If you're using on demand, what happens is you'll get a bunch of throttle events, but then the table will start scaling up the capacity, and then those throttle events will kind of go down. So you want to make sure that in your code you are handling for those because they're going to happen if you get a bunch of traffic or you're doing some type of heavy reads or heavy writes all at the same time. And of course, there's like other metrics in this table and stuff. Okay, so it looks like our GSI1 index is done. So let's go back and try to do a query based on that. Let's just go ahead and click run. And notice that we do get back, using a search by the order A, we are able to get back user 1 and 2. Okay, so that's kind of how like the GSIs work. It just allows you to do queries based on different PKs, which ends up being very important if you want to get some data back to users. Now, again, there's like more things that I didn't talk about. There's like ways that you can have filter expressions in this. So basically you make the request to Dynamo. Dynamo is going to charge you for all the items that come back. But before Dynamo sends those items back to you, it's going to filter through and kind of reduce the amount of records that are sent over the wire back to your Lambda. So I think it's called like a filter expression. And here is what that kind of looks like. You just kind of say like, filter out the items and make sure that they have certain properties on them. And now these filters, you can actually filter based off of things that aren't PKs and SKs. You can just kind of look at any property on the key and you can filter out by that. But keep in mind that again, you're still doing a full like query against Dynamo. So even if you're filtering by something you think you should only get back like 2 records, if you have thousands of records that don't match that filter expression, but they still match your PK SK that you're looking up, you're going to get those items back and you're going to get charged for them. So I mean, I think that covers a majority of like what I've learned with Dynamo. I'm sure there's other stuff that I didn't explain correctly or I missed over or I kind of skimmed over. And I know this video is kind of all over the place. I would say my final remarks are DynamoDB is a really cool solution that can like infinitely scale up your database. So if you have needs of like a huge amounts of data that you don't want to worry about having to scale up a MySQL database or cluster, DynamoDB is a good solution. I would say that if you're working on a side project or a small business, I would always stick with SQL. SQL is just easier. It gives you more flexibility with the query language. DynamoDB is a completely different way to learn how to store data and read data. It's going to take you a lot of time to understand the best practices. You're going to make some mess ups. And I would say start with SQL, and then if you find places in your application where a NoSQL store would really be good, like let's say you want to break off a microservice because you have like tons of orders, and you say, you know what, I think since we have millions and millions of orders or millions and millions of logs or something, we want to go ahead and just put that in Dynamo because I think it makes more sense for that particular subset of our system. I think building an entire application using Dynamo is a mistake. The lack of relational data and the lack of like joining and stuff like that means that you have to do that all in the node code yourself, and it just becomes a lot more to maintain. But I'm not saying it's a bad solution. I'm just saying make sure you understand what you're building. Make sure you understand if it's relational data or if it's not before you just use Dynamo, because it's going to save you costs, because there's always hidden costs with learning these type of things, maintaining these things, and SQL has been proven to like work pretty well for a lot of applications. So again, that's coming from my 5 years experience of working with Dynamo on a system at work. If I started over, I would probably stick with SQL for that project. I'm running out of steam. This video has been going on for a while, but if you have any things that I've missed out on, be sure to leave a comment and maybe I'll make a follow-up video on this. Like always, I have a Discord channel. You guys are welcome to join if you want to find a place to kind of hang out and talk to other developers or get help. And other than that, have a good day and happy coding.